Um, okay, this is the tendon assembly. Now remember this carefully. There's like 3 sections, and it comes down. They're wavy, and then they get smaller, smaller, and they end up with those little emphasis points, and investing in Sharpie's fibers and bone and tissue. All right, as far as tendons and ligaments and fascia and all that stuff goes, it's all made out of collagen and fibrins and keratins and all this very, very fibrous stuff. And it has a mat. That's the mat of a tendon. And in the mat, it splices off into these little straps. These straps go through what they call a Chinese finger trap, which goes through that, and the ball there invests into the tissue below, or in this case it would be tissue, I'm sure. Now that ball, if you can see that little round ball, that should not be out like that. That should be invested into something. That is a painful thing, I'm sure. And now there is usually 3 layers of ligaments, tendons, whatever you want to call them, connective tissues, and they slide back and forth and do all kinds of things. Now, in order to slide back and forth, they're in their own sheaths, and their sheaths are, coated with, I think they call it synovial fluids and things like that. Now, this particular stuff right here, see that little bumpy stuff? That is what I'm going to call slurpees, which is small leucine-rich proteins. Look at it really careful. I don't know if you can see it or not. Anyway, it's a real bumpy slurpy stuff. And I have that, and it's blood red. And anyway, this is the tendon mat assembly. Alright, that tendon mat assembly and that tendon ball is microscopic. This is a tendon from, I believe, a tendon mat, and they all break in the same place where that strap goes across. This is the slurpees. This is another strap that sat right on top of here, and they slipped across. And that is the fibers that come down through there and into this ball. And that ball usually sits into something, and this one I assume was in cartilage or something like that, in some loose connective tissue. And it pulls out. Now I have other ones where the fibers are missing because they were in some form of a pH condition that ate them out of there. That's how these things form, tendons. Now, that ball, like I said, is the size of, well, it's microscopic. I mean, it's tiny, tiny, tiny. Now, if you look above here, there's the formula for the surface area of a sphere. And if I put in, you have to be positive entry, so I'm going to put in 1 is the radius, and therefore the surface area is 12.57. Now the radius of 1, when you talk about this thing, this radius would be at least, I would say, let's just say 100 times larger. I mean, it's obviously much larger than that, because you wouldn't hardly see this. You need a microscope to see that in this other one. Whoops. Now, so that was a 1, gave us 12.75. Now, if we go for this one, whoops. If we go for this one here, and we say that's 100 times bigger, so that's 1, 0, 0. Now we've got 1.26 times 10 to the 5. If that was 1,000 times bigger, we would have 1.26 times 10 to the 7. I have no clue how big that is, but 10 to the 7 is a lot of zeros. So you understand that the surface area of a ball goes up absolutely phenomenally as the diameter and the radius increase. This was always the skeptic's conclusion, that the tiny diameter of the little tendon balls and the investments would never hold up some big creature. Well, no, wrong. All right, David, this is about how the tendons and the ligaments and even the skin attaches to the layers of the skin. These are some of the investments that I'm talking about. And they come up and they clamp like a ball, just like that. And the skin is on the other side, and they clamp right to the skin, and then there's one on the other side, and it clamps down to the underlayer, and in between is this areolar tissue, which is the loose connective tissue. That's what I'm saying. Now, you're going to have to see if you think I'm correct. Now, this is flesh. All right? So I'm saying the flesh is below. It's on that side. This is this tendon emplacement. And you can see all of the little tags around here. And this is the investment that goes this way, and there's Slurpees on there, or SLRPs they call them, the small leucine-rich proteins. Now, so those invest down in there, and here is one I'm going to show you. This is a fingertip. Let me see if I can get in here and get a little more light. All right, here's the way it invests. If you can see these balls right here, that circular set of balls, that's stuck down this way and held onto the skin. Alright, and it held onto the skin with all those little fibrils. There's another one over here somewhere. Right over here. I mean, they're all over the place, but some of them are very, very prominent. And they have spikes. They literally have spikes that grab just like that into the skin, and the other direction that grab just like that into the basement layer. And I have them in all the transition layers. This one here, you can see the spikes. The only thing that's missing here is the skin. The skin is missing off of this one. Alright? And this one here, the skin is missing. It's what they call degloved. That outer layer of connective tissue is gone. It would have hooked into these angular slots all over the place. So that's degloved. And this one is completely degloved down to the basement layer. All the areolar tissue is gone until you see the emplacement of the artery, which I always tell you blows out, which it does. And then the vein side does not blow out because it's clamped. You know, and there's a vein right there. It leaked a little bit, but they clamp. And the veins are the ones that always leak. And I have this over and over and over and over and over. And this is where the areolar tissue would have invested into this basement layer. And then that layer wraps the bone, which this is the silhouette, exact silhouette of a human fingertip. And it even has the apical tuft on the end, which is the gnarly little thing that holds all these little balls. And that's what it is. And these are from big creatures, but this is nothing. I mean, this is the way you see it, and you're going to see it in a minute, because I told you, I have never shown anybody on the face of the planet this yet. You're the only ones to see this. Well, the first, because it's going on the internet, but I'm just done hiding this stuff, because it's time to let it loose, that's all. All right, David, so you saw the skin investment. That goes down and grabs and turns around this way and grabs. So that's between the areolar tissues. And I'm sure it goes other places. But it's very characteristic. I have a lot of examples of it. Now, then you go into the bone implant. And that's where you get this. That's a regular ball. And inside that ball, if you can see, there's all those little holes. Those, I believe, are the Sharpie's fibers, or at least they're tendrils of some sort. And they may, but anyway, this is all, this is something, I don't want to go into too much detail, everybody will get bored. But that is this type of implant. Now there's other types of bone implants that hook into these, see that right there? That is where a ligament attaches. And this one over here, there's another one. All right. All right. And that's what makes that bone do what it does. Now this is cartilage, and it goes all the way across over to here. It's cartilage. And that's when this wears down, you get hurt. And these are your, I believe those are blood supplies. I'm not exactly sure, but that's the arterial foramen. This here, these little holes, they call those canaliculuses, and those are blood supplies, the canals. Now, the whole thing is wrapped with fascia, and there's a triangle. I don't know if you can see it or not. I suppose you can see it. The way this is, it's called tunica in the Greek days, and it wraps around and invests itself just like a tunica. You know what I'm talking about, tunica. And it's a fabric blanket that wraps around the bone. And now this, I would like to have Fabio and Jesse take a look at this, because I'm sure this will scan. Well, I'm not positive, but if it would, it's going to be really interesting, because you'll be able to see the distinction between a cartilage. You know, there is actual cracks in here, and that would come off. And you know, in my other videos, I show the strip bones, the differences. You guys have probably, I hope you've seen it. Anyway, that's the bone investment type. And then you also have the one I just showed you a minute ago, which is this one here. These are like triangular investments. They go down and out, and they fill right into these triangles, and there's Sharpie's fibers everywhere. And then they come down and attach into the muscles with these little flaky, pine cone looking, shingly looking things. And that's attaches to ligaments. And those are what I find. Now, in addition, obviously, fascia, this is exactly what we're talking about, and this is on everything. And David, I believe your exact words were that I'm 100% correct in what I'm saying about this. So I need you to be with me to say that to people, because it's true. And you're one of the only ones that understands it. So I need you, brother. So anyway, get back to me on this one. But anyway, I'm going to show you some more in your field, and everybody else will see at the same time. And I'm going to show all the different things that I need to have tested. Alright, this is important to understand. That's the little strap that runs from the tendon mats down onto that ball. And that ball, it looks round in there, and perfectly round, but it isn't. It's a spiky little, really spiky ball, and I'll show you what it looks like. That is supposed to be inside of something. Now, sometimes it goes into, I'm not sure where it goes. David will know about that, but that is supposed to be implanted, and that's what holds it. And it anchors this, and the mat does what it's supposed to do and pulls your fingers around and stuff. Now, this is my representation of what that does. It's a flat mat. It comes out, and there's Slurpees on the top because something slides across it, and it lays there and digs right in just like that into tissue below. And these always have two very apparent blood holes on the sides. Now, that is a tendon implant. You saw the one I just showed you, the little ball. That little ball is literally the same size. Well, the little ball on this one, this is a microscope shot, which obviously this is like 1,000, 2,000ths of an inch. I don't know, whatever they are. They're not very big at all. Now, I told you to hold on here, buddy. Here it comes. This is the size of the tendon enthesis balls that I am finding, and that is a ball right there. There was two of them. One slid across the top. That's the Slurpee layer, and that is the strap that ran back. There would have been a ball attached to here. You know, I cut it off, and this ball was just absolutely totally round, just like a baseball. You see the architecture of it, totally round. And this, inside there, those little white flakes are the fibrils that come down and implant into whatever it implanted into, the bone or the tissue below. And this is the external surface of the tendon. It's a layer. It could be the you know, the periosteum, I think they call it, or it could be the fascia, but it has that same material, tunica fabric in there. It's very apparent under the microscope. Now, those invest in the bone, and this is thousands and thousands of times bigger than what is in a human.